As we've seen, the moment produced by a couple, which we refer to as a couple moment, is not dependent upon the point at which the moments are summed about. The the situation is not the same for an arbitrary force system, such as shown here. So we have a force F1 and a force F2. Their vector representations are given down here. And we can see that the moment about point O is due to an x component of F1 times its moment arm of 5. So we can see that that is going to produce a clockwise moment. So it comes in here as a negative. Then we can look at its y component, has a moment arm of 2, and that causes counterclockwise rotation. So it's going to come in as a positive. And now the force vector F2 doesn't have an x component, and its y component is in the positive direction with a moment arm of 4, which causes counterclockwise rotation, which is positive. So putting in the values, we find out that the total moment about point O is equal to negative 37 Newton meters. So the general moment produced by these two forces about point O is a clockwise moment of 37 Newton meters. Now if I do the same calculation of the moment produced by these two forces about point A, we see that the force vector, the x component of F1, has a moment arm of 1, and in this case causes clockwise rotation, so it comes in as a negative. Its y component has a moment arm of 3 and again causes clockwise rotation, so again comes in here as negative. And finally the force vector F2, its y component has a moment arm of 1 and again causes clockwise rotation, again coming in as a negative. So putting in the actual values, we find out that the moment about point A due to this force system is a negative 72 Newton meters. So we can see that the total moment produced by a force system when it's not a couple is actually quite dependent upon the point at which the moments are summed about. And we say that here. All right. What would happen if we now do the same calculation for a parallel force system? In this case, much what we did in the previous video, and we're going to rotate this force vector, make sure its lines of action are parallel, and we can see that F1 is 25I plus 10J newtons, so F2 now is just the negative of F1, so negative 25I minus 10J. So to make it easy to do these calculations, let's come in here and put in the force vectors as broken up in their Cartesian components. So we can see that the moment about point O here is going to be a negative F1 times its moment arm of 5, just like what we did in the previous slide, and its y component is have a moment arm of 2 being positive, but now F2x points in this direction, which is producing a clockwise rotation at a moment arm of 2, so it comes in here as negative, and again the force vector, the y component of F2 has a moment arm of 4, which again is causing clockwise rotation. So of these four components, only this one, the F1 acting at a moment arm of 2, is the only one that's causing a positive moment. So we put in the values for the respective components, and we find out that the total moment about point O is negative 195 Newton meters. If we do the same thing for the moment about point A, so the x component causes a negative moment at a moment arm of 1. Its y component again has a moment arm of 3, again comes in as negative. Now the F2x component has a moment arm of 7 and again causes clockwise rotation. And in this case, it's only F2y, this 10 Newton force with a moment arm of 1 is the only one that causes a clockwise or positive moment, designated here by the plus sign. So again, we put in our values, and we find out that the moment about point A is exactly equal to the moment when calculated about point O, which is equal to negative 195 Newton meters. So the moment produced by the force system that forms a couple, which this does, is referred to as a couple moment, and the magnitude and direction of the couple moment is independent of the point about which it is calculated. All right, we can look at this one more time. And in this case, let's just look at the two Cartesian vectors, the vector couples that are formed. So in other words, we have a 25 Newton couple with the distance between them of being 7 meters, and we have a 10 Newton couple with the distance between their lines of action as being 2 meters. So we can take any given set of Cartesian any vectors that form couples, break them into our Cartesian components, and then calculate the moment using two couples that are broken into their Cartesian components. So in this particular case, the total moment, now it's not being calculated about any given point. We look at the 25 Newton force, and in general it's causing a clockwise rotation, not about any given point, just on any, just looking at the figure itself, it's causing clockwise rotation, and it has a moment arm of 7 between the lines of action, and the 10 Newton force with its distance between the lines of action of 2, again in general causes clockwise rotation, which in this case, again, to no surprise, produces a total moment, or in this case, as we're going to call it, a couple moment of 195 Newton meters. So we can note that the moment is represented without a subscript because, as we say, the couple moment produced by a couple or a set of couples is not dependent upon a reference point. Now, we can take a look at one last thing, and if we want to find the perpendicular distance between the lines of action of the two forces, we can utilize the formal definition of the couple moment, because the formal definition is that the couple moment produced by a couple is equal to the magnitude of the force vector times the perpendicular distance, which in this case is 195 Newton meters. So down here we are using the square root of the sum of the squares to determine that the magnitude of the force is 26.9 newtons, and that allows us to calculate that the perpendicular distance between the two forces is a total distance of 7.24 meters.